So I think I want to leave a few minutes for questions, assuming I can do this remotely. But basically, our conclusion was cloud technologies for data-intensive applications are pretty promising, things like Hadoop. I didn't show you any graphs today from MongoDB, but that's something I'd be happy to share with anyone who's interested, are pretty useful, but they don't work out of the box for cloud computing for science clouds. And essentially, if we look at clouds, it's a business model, and it can be applied in different environments. And it's just a collection of different technologies and ideas that have come together. And the definition of cloud is definitely varied depending on whom you talk to. But the current day cloud computing commercial solutions have gaps for science. And actually, commercial solutions as well as sort of the open source ones have performance, reliability, stability gaps. The programming models are difficult. The security mechanisms, especially for labs like DOE labs, are not quite sufficient. They would require extensions to work in our environment. And the reality is that some of these technologies and mechanisms and ideas can be applied at HPC Center, which would help other diverse workloads be able to share these support for these HPC centers like data-intensive workloads, have more custom software environments, and maybe the ability to provide different levels of service. So that's the end of my presentation. I'd be happy to take questions at this point. I'm not quite sure how that works. Let me, I guess, stop sharing this so I can look at my other stuff. So
we can use the Jabber to ask questions. I mean, we can talk, so
okay.
Questions.
Yeah.
So I had a question. Is it DOE looking at working on Hadoop and things like that, and producing a scientific MapReduce?
That's actually a good question. The DOE doesn't have an official cloud computing program as such. There's definitely a couple of different initiatives that are coming out recently. One of them, the Collaboratories program, we actually just got funded to do some, with Argonne, do some work in looking at building tools to use these virtualized cloud environments for elastic applications and work through sort of some of the the software level issues and trying to figure out how do you do the right data management strategies and stuff. If someone's interested, please feel free to drop me an email. We're also we have a couple of application partners, but if we have more use cases, that would definitely be of interest. We also have another project funded here, which is beginning to look at how you could take some of the ideas from MapReduce and apply the same ideas to a more generic set of workflow patterns that are more available in the cloud, in the sort of scientific workspace, and how they would run in both HPC and cloud environments. That was also a recently funded project here. And I should probably also say this, that we are hiring, so if anyone's looking to do some cool, interesting cloud work, do contact me. So.
Any other questions?
UCL has two questions. First question is that in the first part of your talk, you mentioned that your virtual machines were choking the net because of the network bandwidth. Is that because all your outside network is going through a single cloud controller? Is that the place where the bandwidth was choking?
It's not outside. It's basically when you're doing communication, what we were running were MPI jobs, and when you do communication across the nodes in your virtual cluster, all the communication goes through the cluster controller, which is the central point. This is Eucalyptus version 2, which we were using. It could have changed in Eucalyptus 3. I haven't quite been following the networking aspects, but I believe it's still the same. So what happens is essentially the cloud controller node manages the network for all the virtual machines, so it ends up being the bottleneck.
Okay. My second question, rather a comment, is that your comparison between GPFS and HDFS, and one thing is that GPFS is very expensive. HDFS is...
Yeah, I was going to, that's a good point. I was going to say that, and I probably skipped saying that. I usually say that every time I show the graph, that it's somewhat comparing apples to oranges, because one is $1 million file system. But I think the way we looked at it a little bit was, we have a lot of users who already have tons of data on our GPFS file system, right? So the question is, when they have data analysis that they need to do on that data, what's the most efficient way for them to do it? Does it need them to move all that data to HDFS to get the performance of HDFS for what they were doing, or can they leave the data on GPFS and just do the analysis? And that's why that graph, all that comparisons were done. And so our conclusion was that if you already had a lot of data in GPFS, and if you didn't have, you weren't going to run at a large concurrency, then you could just leave the data on there. And the cost of moving data to HDFS is still fairly high. So you sort of have to make, these are soft decisions where you have to make decisions based on what you're going to do with the final data. Do you need it to be sitting in HDFS? Do you need it back in GPFS to do something else in your pipeline?
Thanks.
We have a question here from Indiana. So what's your question? Do they have
any metrics or application that value a specific program is more suitable to run on cloud environment or HPC?
Well, so the question was, do you have programs that can act metrics that can compare cloud and HPC? Is that the question?
For a given program, if a scientist has a program, and then should we use cloud to run or?
Oh, so the question is, do you have well-established metrics so that somebody with a program can decide whether to use a cloud or an HPC system?
We do have a performance metric that we use, which we call SSP, the sustained peak performance here on the NERSC systems, and that's what we used for our initial evaluation. I think it's not an entirely a quantitative answer, which is why we didn't really go down that path in the project. It's a qualitative answer as to how much effort and time it's going to take you to run, get your stuff ported and running as well. So.
And do you think that it's possible to create something like that with your experience? Because it could be very useful, like, for example, for the RAIN or Comet cloud to eventually become.
So the question was, do you think it's worth investigating this issue?
Maybe. It's unclear to me that you can come up with one benchmark or one metric that would encompass a large number of applications in the cloud. This performance is important to some people, but there's all kinds of issues there. It's like coming up with any other benchmark, those same challenges. So.
Okay, so I think it's now is the time for the traditional virtual applause.
Thank you.
And we thank Lavanya, and we're proud that she came from Indiana University. And thank you.
Thank you. Thanks, Jeffrey.